Today we're going to talk about scale drawings and scale models, so make sure you're on 6.3, the Reading to Learn side first. We're going to come down here and do some definitions first, and then we'll do some examples on the other side. So we're going to talk about what a scale drawing is. Scale drawings are used to represent an object that's too large or too small to draw actual size. So you've used these in social studies, would be maps, blueprints would be another thing, or even drawings in your textbook of things like atoms or stuff like that or cells that are too small to see. They would make drawings of them. So the definition, they are used to represent an object that's too large or small to draw, I'm going to put down here, or build actual size. So this scale model is the exact same definition, but you would say build instead. It represents an object that's too large or too small to build. So this would be flat, this would be three-dimensional. That's the only difference. So we said things like maps, blueprints. In textbooks, you'll see pictures of different things, like I said, like an atom or a cell. Models, those would be three-dimensional. So there are some people that make model cars, and everything has to look exactly the same, so it's scaled down so that it looks identical, just small. Model airplanes, I'm going to put airplanes here. Some people build model airplanes that look exactly like a regular airplane. You might have like body parts, like ears, things that are too small. When a doctor is going to put tubes in someone's ears, they show them a model of an ear, but they don't show the actual size because it would be too small. So they usually have a larger size. Even like your mouth, when you go to the dentist, they'll have a bigger version of your mouth to show you how to brush your teeth. So those are models. A scale itself gives the relationship between the measurement on the drawing and the real one. So that would be like on your map. If you use maps in social studies, you'll see a scale on there. It might say like 1 inch equals 500 kilometers or something. Whatever it happens to be, depends on the size of the map. So that's telling you that every 1 inch on the map is really 500 miles or whatever in real life. So the scale gives the relationship between the measurement on the drawing or on the model, I'm not going to write that, and real object. So it could be written like this: 1 inch equals 3 feet, meaning every 1 inch on my drawing or my model is really 3 feet in real life. Sometimes they don't put the units, and they'll just put a ratio written like this and say 1 unit is actually equal to 24 of the units, if they don't put the actual measurements on there. A scale factor is a little different than a scale, because a scale is two different units. So if I have a unit of measure, I can have inches and I can have feet, and that's okay. A scale factor is a ratio, and as we learned, ratios have to have the same units. So if you end up with a scale, you can turn it into a ratio by making them the same units. So it's a ratio of the length of the scale drawing to the corresponding, meaning in the same spot, corresponding length of actual object. So if it's the same already, 2 inches to 16 inches, see how they're the same inches already, so we could just say that's 2 to 16. Since they're both inches, we're good, and that would be in the scale factor would be 1 to 8. That means the drawing is 1/8 of the real size. How is the scale different from the scale factor? The scale factor is a ratio, and has to have same units. And we'll do one on the other side where they're different. Okay? All right, turn your page. I have a set of landscape plans that shows a flower bed that is 6.5 inches wide. The scale on the plan is 1 inch to 4 feet. So when I'm going to make proportions to find missing lengths, either on the drawing or on the actual. And so I'm going to need this scale that is always given as one part of the proportion. It's always just going to be the first ratio of the proportion, the left fraction, I guess you would say. So I want to know what the width of the actual flower bed is. So we're going to let X be the width of the flower bed, okay? And we're going to write and solve a proportion. So when I make my proportion, I want to make sure that the tops are the same as the bottoms. And the bottoms are the same, okay? So the plan numbers and the actuals numbers. Actual. Why I put an S there, I don't know. Okay. So in the scale, it's 1 inch is really 4 feet. So the plan is the inch, the actual is the 4 feet. What I do know is that I have 6.5 inches. I have 6.5 inches in the drawing, and I want to find the actual length of the flower bed. So that's my X. So I'll cross multiply. I love when I have 1 times X because it's just X. I don't have to worry about dividing after. And then 4 times 6.5, you can do on your calculator, is 26 feet. If there was another number besides 1 here, we would then solve that one-step equation as well. I'm going to find the scale factor. We're going to write the ratio of 1 inch to 4 feet in simplest terms. So I'm going to find a scale factor. And we said the scale factor has to be in the same units. So right now my scale is 1 inch to 4 feet. Now remember, we can multiply here and do cross to cancel out because we want to cancel out all the units. So I have 1 foot to 12 inches. So it's 1 to 48. That means that each measurement squeeze that in there on the plan is 1/48 of the actual. So the actual would be 48 times bigger. It's 1/48 of the actual. Finding a scale. The inside of the Lincoln Memorial contains 3 chambers. The central chamber, which measures the marble statue, has a height of 60 feet. Suppose a scale model of the chamber has a height of 4 inches. What is the scale of the model? So right now it says that every 4 inches is 60 feet, but when we make a scale, we don't say 4 inches, 2 inches, 5 inches. We always want it to be something easy like 1 inch. So anytime you're going to make a scale, you're going to put 1 inch. So we're going to write the ratio of the height of the model to the actual, solve the proportion, which the height of the model is 1. So anytime I want to make a scale, I want it to have 1 inch equals so many whatevers. And so then that's the X here, okay? So I'm going to go 4 times X is 4X, and 60 times 1 is 60. I'm going to divide both sides by 4, and I get 15 feet. So that means, that goes here, that means that 1 inch is equal to 15 feet. This is a much better scale than saying every 4 inches is 60 feet. Every 1 inch is 15 feet. So anytime we make a scale, we want to make sure it has a 1.